Welcome to G Fun Facts Online. Today we are going to talk about a Leviathan hiding in the dark, a structure so massive it defies our current understanding of how solar systems are born. We are traveling 1,000 light-years away to the constellation Cepheus to look at an object that sat unnoticed in astronomical catalogs for decades, only to recently reveal itself as a record-breaking monster. This is the story of the impossible disk, also known by the incredible name Draculas Chivito. Let's dive right in. The universe has a fascinating habit of hiding its most gigantic secrets in plain sight. For years, astronomers had a catalog entry known as IRAS 23077 plus 6707. To the automated surveys sweeping the sky, it was nothing special. It registered as a faint source of infrared light, likely just another young star wrapped in the dusty cocoon of its birth. It sat there, an unremarkable line of data until 2016. That year, the Pan-STARRS survey in Hawaii, which stands for the Panoramic Survey Telescope and Rapid Response System, captured data that caught the human eye. A team led by Dr. Ciprian Bergea was actually looking for something else entirely. They were trawling through data searching for active galactic nuclei, which are supermassive black holes feeding in distant galaxies. But they noticed an object that didn't fit the profile. It wasn't a distant galaxy, it was much closer, and it had a strange shape. Initial images showed a dark horizontal lane cutting through two bright, glowing lobes. It looked less like a star and more like a cosmic hamburger floating in the void. Now in astronomy, this is called an edge-on orientation. Usually, when we look at protoplanetary disks, which are the flattened rings of gas and dust around young stars where planets form, we see them at an angle. They look like ovals or bright rings. But seeing one perfectly from the side is a rare gift. It allows astronomers to block out the blinding glare of the central star and study the vertical structure of the disk itself. But it wasn't just the orientation that was special. It was the sheer scale. As researchers calculated the dimensions, the numbers seemed wrong, they seemed impossible. This disk extends across an area of the sky that, at its distance, translates to a physical width of nearly 400 billion miles, or 644 billion kilometers. To put that into perspective, the distance from Earth to the Sun is 93 million miles, which we call 1 astronomical unit, or AU. Neptune, the farthest known planet in our solar system, orbits at about 30 astronomical units. The Kuiper Belt, that ring of icy debris at the edge of our planetary neighborhood, goes out to about 50 astronomical units. IRAS 23077 plus 6707 spans over 4,000 AU. This single structure is 40 times larger than the diameter of our entire solar system out to the Kuiper Belt. It is so vast that if you were to drive a car at highway speeds from one edge to the other, it would take you over 700 million years to complete the journey. It is the largest protoplanetary disk ever discovered. It is a factory for planets on a scale we didn't think was possible. Now, before we get into the physics of why this object should exist, we have to talk about its name. In the serious world of academic papers, astronomers often find joy in nicknames. The most famous edge-on disk prior to this was called Gomez Hamburger. But when Dr. Bergea and his co-author Dr. Christina Munch analyzed this new giant, they knew it needed a name with more character. The name Draculas Chivito was born from a collision of cultures. First, Dracula. The lead author, Ciprian Bergea, grew up in the Transylvania region of Romania, the legendary home of Count Dracula. But the connection wasn't just geographical. In high-resolution images, the northern part of the disk features faint, wispy filaments of gas extending away from the main structure, looking exactly like the fangs of a vampire. Second, the Chivito, the object's hamburger shape. That dark dust lane sandwiched between two bright halves reminded co-author Ana Mosquera of a national dish from her home country of Uruguay. The Chivito is a rich, towering sandwich loaded with steak, ham, cheese, eggs, and mayonnaise. It is a monster of a sandwich, fitting for a monster of a disk. So we have Draculas Chivito, a name that is spooky, appetizing, and scientifically descriptive. But what are we actually looking at? Structurally, this is a protoplanetary disk. It is a rotating pancake of dense gas and dust surrounding a newly formed star. These disks are the leftovers of star formation. When a giant molecular cloud collapses to form a star, the angular momentum flattens the remaining material into a disk. Over millions of years, dust grains stick together to form pebbles, then boulders, and finally planets. But Draculas Chivito is a system in turmoil. The defining feature is that dark band running through the center. This isn't empty space. It is actually the densest part of the disk, so thick with dust and gas that it completely blocks the light of the central star. We are seeing the shadow of the factory floor, where planets are being built. Above and below this dark lane are the glowing buns. This is starlight escaping from the poles of the star and scattering off the dust in the upper atmosphere of the disk. The fact that these buns are so bright suggests the central star is massive and luminous. stripping away the surrounding cloud with intense radiation. Then we have the fangs. This is where the science gets really interesting. Hubble's Space Telescope images revealed that the disk is surrounded by faint, wispy filaments extending billions of miles into space. Crucially, they are asymmetrical. They appear on the northern side, but are almost absent on the south. As Dr. Christina Monch noted, the level of detail is rare. We are seeing the disk's wispy upper layers, and that asymmetry implies violence. The disk isn't a calm island. It is likely interacting with its environment. These filaments could be stellar winds blasting material out, or perhaps fresh material from the surrounding cloud raining down onto the disk to feed it. It could even be the result of a flyby, where another star passed nearby and dragged streamers of gas out of the disk with its gravity. This chaos challenges the serene image we often have of planet formation. It suggests baby solar systems are turbulent places, constantly being shaped and torn by external forces. So why do astronomers call this disk impossible? It comes down to accretion theory. A star grows by pulling in material, but gravity isn't the only force. Gas at the outer edges should dissipate or be stripped away by radiation from nearby stars. In our own solar system, the dense part of the disk probably ended just beyond Neptune. For a disk to sustain a radius of over 3,000 AU, it requires specific conditions. First, there is the mass problem. Estimates suggest Draculas Chivito contains between 10 and 30 times the mass of Jupiter in dust and gas alone. That is enough to build thousands of Earths. Usually, that much material would fragment to form companion stars, not stay in a single disk. The fact that it hasn't fragmented suggests it is hot or turbulent enough to resist collapse, yet stable enough to remain bound. Second is the photoevaporation problem. Massive disks are usually found around massive stars. But massive stars emit huge amounts of UV radiation that typically boils away their disks before planets can form. This object must be in a delicate sweet spot, young enough to survive the radiation, but old enough to have settled into a disk. And then there is the planet formation paradox. Current theories like pebble accretion work well in compact disks. But in a disk this large, orbital periods are immense. A planet forming at the edge would take thousands of years to complete one orbit. At those slow speeds, dust collision happens in slow motion. Can planets actually form 2000 AU from their star? If they did, they would be frozen super Neptunes orbiting in eternal twilight, where their sun looks like just another bright star. This brings us to a fascinating reflection. Objects like Draculas Chivito act as a funhouse mirror for our own history. 4.5 billion years ago, our sun was a young star with a similar, though smaller, disk. The chaos we see in the Chivito, the infalling gas, the turbulence, might have played a role in our own system. Did we once have wispy filaments stripped away by passing stars? Did a feeding frenzy of gas trigger the rapid growth of Jupiter and Saturn? The sheer size of this object raises a provocative question. Was our solar system once much larger? It is possible our sun's original disk extended much further out, but was pruned by the gravity of neighbors in the crowded cluster where the sun was born. Draculas Chivito might be what a solar system looks like when it grows in isolation, free from cosmic pruning. Or, it represents a scaled-up version of a solar system. If life ever evolved there, their space race would be infinitely harder. A probe to their equivalent of Pluto wouldn't take 9 years, it could take centuries. The discovery is just the beginning. The images we have are from Hubble, but the true secrets lie in wavelengths our eyes cannot see. The James Webb Space Telescope, or JWST, will likely target this object. JWST sees in infrared, meaning it can peer through that dark dust lane. It could reveal the central star. Is it a single giant, or a binary pair dancing in the dark? It could detect the heat signatures of newborn planets hidden in the gloom. It could even analyze the ices in the disk, water, ammonia, methane, to see if the ingredients for life are present. Meanwhile, the ALMA radio telescopes in Chile can weigh the central star by measuring the spin of the gas and map where pebbles are clumping together. In conclusion, the impossible disk is a reminder that the universe creates things bigger than we can imagine. Just when we think we understand the limits of star formation, we find a structure 400 billion miles wide, named after a vampire and a sandwich, floating in Cepheus. It is a cosmic laboratory where the laws of physics are tested on the grandest scale. Draculas Chivito exists, and because it exists, the universe is a little more magical and a lot more mysterious than it was yesterday. Thanks for listening to G Fun Facts Online.